Hi, my name is Abhishek Choudhary, and I have built this Bhasa Agent voice assistant. And let's begin with the problem statement first. So, India runs one of the largest welfare ecosystem in the world. The government currently operates over 740 centrally sponsored schemes and thousands of state-level sponsored schemes, touching everything from farm subsidies to disabilities to pension to education scholarships. But here what the problem is. Most of them schemes go unclaimed. According to a study in 2023 by the Center for Monitoring the Indian Economy, nearly 40% of the eligible beneficiaries never apply for the scheme they qualify for. That's not because the scheme doesn't exist, but because the people simply don't know about them. They can't navigate the bureaucratic language or can't access the information in their own regional language. So let me give a concrete example. A daily wage construction worker in Bihar, let's call him some, let's call him Ramesh, is eligible for at least six different welfare schemes: housing under PM Awas Yojana, healthcare under Ayushman Bharat, an accident benefit, a pension scheme, and two education scholarship for his children. But Ramesh speaks only Hindi and Bhojpuri. The scheme portals are mostly in English. The application process are buried in PDF documents, and our nearest common service center is at least 15 kilometers away. This is fundamentally information access problem and it's hard for specific reasons. First, the language problem. India has 22 officially recognized language and over 90,500 dialect. The government scheme information is overwhelmingly published in a English and formal Hindi language. A farmer in West Bengal who speaks Bengali or a tribal woman in Maharashtra who speaks Marathi, they are effectively locked out of the information layer. So it's a literacy interface problem. India internet penetration has crossed 52%. Yes, 52%. But digitally literacy remains at roughly 38%. Text-based search and voice-first interface has to discover welfare scheme. From heavy portals don't work for this demographic. The user are comfortable with voice. The use of voice on WhatsApp, they all call customer care, but there is no voice-first interface to discover welfare scheme. So third, it's a scale presentation problem as well. With 172 schemes across six states in our knowledge base alone, the system needs to understand the context which state the user is from and what category they need, whether they are eligible and responds real-time conversationally in their language. So the question I ask myself, can I build a real-time multilingual voice AI that lets anyone regardless of the language or literacy discover, understand and then apply for government welfare scheme just by talking? And that's when I built Bhasha Agent. Let's get started with the demo first. This is my minimalist UI and the Bhasha Agent voice assistant is what it's called. This is a tweak button basically. It's enable the VAD and start detecting our voice as soon as I click on this. And let's say I am a student from Bihar who wanted to know about schemes in Bihar. So let's see if it can give me schemes related to Bihar as a student or not. And also let's speak in Hindi and try to fetch answer in Hindi as well.
Hello, I am Basha Agent, your voice assistant for government welfare schemes. Which state are you from? And what kind of scheme are you looking for?
मैं बिहार से हूँ और मुझे स्टूडेंट स्कीम जानना है।
बिहार में कई स्कीम्स हैं जैसे मुख्यमंत्री बालिका प्रोत्साहन योजना जो लड़कियों को ग्रेजुएशन कंप्लीट करने पर 2,500,000 की एक मुश्त प्रोत्साहन राशि देती है। क्या आप इसके बारे में और जानना चाहेंगे या कोई और स्कीम देखना चाहेंगे?
मुझे स्टूडेंट क्रेडिट कार्ड योजना के बारे में जानना है।
बिहार स्टूडेंट क्रेडिट कार्ड स्कीम के तहत आपको 4 लाख रुपीस तक का लोन मिल सकता है। क्या आप इसके बारे में और जानना चाहेंगे या एलिजिबिलिटी चेक करना चाहेंगे?
क्या मुझे इसके बारे में और बता सकते हैं?
बिहार स्टूडेंट क्रेडिट कार्ड स्कीम के तहत आपको 4 लाख रुपीस तक का लोन मिल सकता है जो आपकी हायर एजुकेशन के लिए उपयोग किया जा सकता है। इस स्कीम के लिए आपको कम से कम जेप्ट पास होना चाहिए और आपकी उम्र 25 वर्ष से कम होनी चाहिए। क्या आप अप्लाई करना चाहेंगे या इसके लिए अपनी एलिजिबिलिटी चेक करना चाहेंगे?
हाँ, मुझे अप्लाई बटन मिल सकता है क्या?
अब आप स्कीम कार्ड देख सकते हैं और अप्लाई बटन पर क्लिक करके आपका एप्लीकेशन फॉर्म भर सकते हैं। क्या आपको एप्लीकेशन फॉर्म भरना है या मुझसे कोई और मदद चाहिए?
नहीं, थैंक यू वेरी मच। कॉल एंड कर सकते हैं। This is how you get the scheme card. Basically, it has all the scheme. It shows your document required, application process, the benefits and the overview, eligibility, and other things. You can either go to the form link or you can either dismiss it. And it also has different languages as well. You can convert it into Hindi and see the full whole document in Hindi and you can convert it into English. For Bihar state, I try to make it in two language in Hindi and English, but for other state like Maharashtra and West Bengal, we try to make it in their regional language, Marathi and Bengali as well. Thank you very much. Now moving on from the demo, let's talk about the data foundation, system architecture and the components. So before building the agent, I really needed a rock solid knowledge base. I started with scraping data from the official government scheme portal. This was a significant hurdle. The site was robust, uses complex session handling, and are not easy designed for extraction. But I still pulled it off. Once I successfully extracted the data, I didn't just jump to the database. I wrote a custom processing script to enrich the data with metadata. As you can see in the JSON structure on the screen, every schema is mapped under specific tags for same state, category, precise eligibility, criteria like income caps or age. This structure approach is what allows the AI to perform a surgical lookup rather than guessing from a wall of text. Now, let's move on to the vertical data flow diagram. So yes, this is my data flow diagram. So most developer solves complex AI tasks by building high overhead routing layers or implementing a model context protocol servers. I took a different path. To keep the cost at zero latency at its absolute minimum, I engineered direct tool execution. Instead of using a expensive routing layer that decide whether to send a query to LLM equipped with specialized tools that interacted directly with the JSON, we saved us a significant API overhead and kept our processing loop incredibly light. The real-time pipeline follows this linear flow. At first, the user speaks, the VAT detects the language and automatically sends the packets to the STT for transcription. And then when it detects the pause, it actually sends all the packages to the STT for transcription. Then the brain. We use Llama 3.370 billion. And why Grok? Because it provides sub-second inference. The the LLM identifies the intent and uh, immediately triggers a search schema tools. Basically, search the tools schemas for the relevant schemas. Then we return the data from the knowledge base, and LLM generates finally a response. This then goes to the TTS, which generates the synthesize the basic speech. So we use Cartesia Sonic. This is a streaming TTS engine. It doesn't wait for the LLM to finish the whole paragraph. It starts speaking as soon as the first sentence is generated. So part three, the parallel outputs and execution. Uh, let's move on to the system architecture. So we have our user interface that has microphone, visual cards, and the speaker basically. And then we have our AI services and a fast API background with fast RTC and web sockets. So the magic on the Bhasa AG is parallel agent is its parallel execution. So let's talk about this. When the LLM finds a match, the term loans scheme for monetary, it does two things. It pushes the scheme card to the Next.js frontend via sockets. This card contains the pre-translated details, document required, and for the application process. So it begins streaming the audio answer back to the user. This dual track ensures that the user hears from the information and sees the actionable card in 2 seconds. The session remains live and the conversation maintaining context until the end tool call is triggered by the agent to terminate the session gracefully. So by focusing on the structured data and direct tools calling over heavy infrastructure, I have built a system that isn't just smart and it's fast enough to actually be useful in the real world conversation. That is the architecture of the Bhasha agent. Now let's just quickly take a look at our trade-offs. So when you're building a voice AI, you're fighting with a war against millisecond. My first major trade-off was choosing inference between speed over model size. So I could have used ChatGPT 4.0 for slightly higher reasoning accuracy, but 3 to 5 second latency kills the human feel of a conversation basically. So instead, I opted for Llama 3.3 70 billion parameter on Grok. By sacrificing that marginal top tier reasoning, I basically gained a sub-second inference latency. So in a voice, a faster answer that's 95% right is better than a perfect answer that basically arrives 5 seconds late. So let's talk about another trade-off, which is RAG versus direct tool calling. So then there is a data retrieval trade-off versus structured tool calling obviously. So most developer throws a PDF into vector database and hope the best. But for government scheme, hallucination are dangerous. Obvious reasons. I traded the flexibility of a standard RAG for the rigidity and the structure of the JSON tools. By manually structuring the scrap data into searchable schemas, I ensure the LLM doesn't guess eligibility. It perform a basic surgical lookup. It's more work upfront, but it guarantees accuracy while keeping the context small and latency lower than the retrievals. Then another would be the legacy infrastructure versus cost. So let's say finally, uh, the legacy infrastructure like Twilio or WAPI offers reliability, but they come with a high per minute cost and black box latency. That means you can't see how why they are why they are have high latency or why basically they do not work like as we expect. So I choose to pivot to fast RCC and web RTC. It's a trade-off between development time. I had to handle complex web RCTs handshakes and audio buffering myself, but the result is a zero cost infrastructure that provides a direct low jitter path between the user and the server. So I traded the convenience of a paid API just to control over the audio pipeline. So this doesn't only make my infrastructure low cost and cost efficient, but it also helped to have most of the control with myself. And by making this specific trade-off, I prioritize the speed over the model size, structure our vector search, and open source protocols over paid gateways. So I built an agent that function at a fraction of the cost without sacrificing the user experience. Now let's quickly summarize this by talking about our failure points. So let's talk about the bad false failure. So background noises like keyboard clicks, door closing, or other noises triggers the voice activity detection. The system handles this by checking the empty transcripts and silently skips the pipeline to prevent the AI from responding to ghosts. So ID hallucination during two limiting crashes. Under high traffic, Grok's tokens limits can cause unhandled exceptions. The engineering fix move involves around wrapping the LLM calls in try except block to provide a graceful high traffic or acknowledgement audio message instead of a hard session crash. And another is WebSocket rejection. The deep ground WebSocket connection intermittently rejects call in free tier. The system is built automatically to fall back on the REST API, which maintains the calls but adds a noticeable 2 to 3 seconds of latency penalty. And lastly, that is state loss. Mid-call networks interruption currently result in a complete loss of conversational history and whatever is held in the memory. Transitioning to a Redis-based persistent layer would definitely solve this production stability problem. Lastly, Bhasa Agent is not just a chatbot, it's a voice first AI that bridges the information gap between India's welfare infrastructure and about 600 million people who need it the most. It speaks their language, it understands their context, and it's put actionable schemes information on their screen with just a spoken request. The code is on the public repo, and thank you very much, Abhishek.